What I'll do in this video is just generate that 45-45-90 relationship between the sine and cosine. And here, if we start with a 45-degree angle, that point right there on the unit circle, so unit circle again, radius 1, that point on the unit circle, well, what are the coordinates of that point? Well, if we want to know the coordinates of that point, we want to come up with the lengths of these legs of the right triangle, and we know that the relationship between the lengths of the legs and the hypotenuse in a 45-45-90 would be that if you start with x being the length of the leg, then x radical 2, if you have to multiply by radical 2 to get from the leg to the hypotenuse, and that means if you have to multiply by radical 2 to get from the leg to the hypotenuse, then you'd have to divide by radical 2 to get from the hypotenuse to the leg. Alright, well, to clean that up, if we rationalize the denominator by multiplying top and bottom by radical 2, we would write that as radical 2 over 2. And then that we know that since this is an isosceles triangle, that both legs have the same length. So it doesn't matter what leg you choose, either one has the same length. And so anyway, the coordinates of the point on the unit circle that corresponds to the 45-degree angle are radical 2 over 2, comma, radical 2 over 2. And so from the last video, you learn that the cosine of the angle is equal to the x-coordinate of the point on the unit circle. Keep in mind, the cosine of an angle is the ratio of the side adjacent to the angle to the hypotenuse of the right triangle. It's a ratio. So if you get a point on any circle other than a circle of radius 1, then the cosine will not be the x-coordinate. This only works when the circle is a unit circle. Okay, so please keep that in mind. It's a common mistake that students make. Anyway, the sine of the angle is the y, and they're both radical 2 over 2. Okay, and so I'm going to flip over to the template that I sent you to on the Canvas site. So you should have printed out the template, and I'll show you what that looks like here. And if you haven't printed it out yet, you'll want to do that because we're going to fill it in together. Okay, so let me zoom out. Actually, I'll zoom back in. And what we'll do here is we'll take this quadrant by quadrant, and we've already done. Let's see. So this is it, and just in case you haven't printed it out yet. So pause the video and print this out if you have not done that. Okay, so this is our focus today. This is going to be our goal, is to be able to not only fill this out, but also fill it out quickly, and then one more thing, fill it out with understanding. Alright, so memorizing where all the angles are, that's good, but you really need to understand why these are where they're at. Okay, so let's start with the first quadrant. Like I said, look at the little degree symbol. So this is the easy part. This is how you'll do it. 0 degrees, we know that's 30, 45, and 60 degrees. And then we have the 90-degree angle at the very top. Okay, and then we have in radians, we have 0 radians. And I'm going to challenge you to be able to write in what the radian values are based on one of the first videos that we did. I think it was the first video for tonight's. And so anyway, pause it and then play. So we should have a pi over 6 right here, pi over 4 right there, a pi over 3, and then we have our pi over 2. Look at the patterns. 2, 3, 4, 6. So the numbers in the denominator get bigger. They all have pi's in them. And also now let's go ahead and come up with the coordinates of each of these points that corresponds to the angle. Coordinates of this point here, just to the right, it would be 1, 0. So this is the unit circle, radius 1. And then if you remember, see if you could fill these out, the coordinates of the point that corresponds to the 30-degree angle, or the pi over 6 angle. And that would be the square root of 3 over 2, comma 1/2. Now maybe these are the division bars. Maybe that's what those are, but that's how they were intended. Either way, I don't care. Just get it in there. And then the point here, the coordinates of the point that corresponds to the 45-degree angle is radical 2 over 2, comma, radical 2 over 2. And then we have 1/2, comma, radical 3 over 2. And then up at the very top, we get 0, 1. Okay, so something to keep in mind. If by chance you wanted to look for patterns here and you just wanted to memorize a pattern, notice that the x-coordinates actually get smaller. The values of the x-coordinates get smaller, and they go from 1 to radical 3 over 2 to radical. So you can see where they go. They go from 1 all the way to 0 through these three values. And you can also maybe think of each of the ones that have a 1 in them as having a radical. So they all have radicals. The x-coordinates go from they all have 2 in the denominator. The x-coordinates go from 3 to 1. Okay, so you have 2 over 2, then you have radical 3, 2, 1, 0. Okay, so 3, 2, 1, 0. The x values get smaller, and then the y values get bigger. 1, 2, 3, 1. Okay, so 1, 2, 3 in the numerator of the y coordinates. Okay, so that's the pattern that you will see throughout this unit circle. So let's go ahead and take a look at the second quadrant, and let's try to come up with some relationships between the angle measures and the coordinates around the unit circle. Okay, so let's go ahead and fill in the degrees. 60, 90 plus 30 is 120, and then you add 15 for the little ones, 135. Oops, I already had the degree there. And then 150, and then you add 30 to get the 180. Okay, and the pi over 3, so we're filling in the radians, so 1/3 of the way to pi, 2/3 of the way to pi, so 2 pi over 3. And then we have the pi over 4, so 1/4, 2/4, 3/4 of the way to pi, or 3 pi over 4. Okay, the pi over 6s are going to be 5 pi over 6, so 1, 2, 3, 4, 5, 5/6 of the way to pi. Okay, now if we built our right triangles just like we did in the first quadrant, we would see that we would still have, maybe it's worthwhile to do this, we can still have this, and I'm going to do it anyway. I'm going to mess up my unit circle, but that's okay. This right here, this angle right here is 60 degrees. That makes that a 30 degrees. That makes this a 1/2. That makes this guy a radical 3 over 2. And so, again, the radius is 1. And so if we want the coordinates of that point, if we go to the left, right, if we go to the left, we're going to go to the left 1/2 of a unit. And if we go to the left, that means we have a negative, that's really hard to get that in there, negative 1/2, comma, radical 3 over 2. So there's all kinds of fun things that we can gather from what we're doing here. Remember, the sine of any angle around the unit circle is the y-coordinate of the point that corresponds to that angle. So we can see that the y-coordinates here are positive. All the y-coordinates are positive in the first and second quadrants. Guess what? That means the sine is positive in the first and second quadrants. So we'll get back to that. Okay, and so we can do the same thing here for these coordinates. We know it's radical 2 over 2 over, so it's negative radical 2 over 2. So basically, guys, if you know the first quadrant, negative radical 3 over 2, comma 1/2, if you know the first quadrant values, or coordinates around the unit circle, then you know them all. All you have to know is that you go from negative to positive. So in the second quadrant, the first coordinate is negative, and the second coordinate is positive. And in the first quadrant, forgot to do that, it's positive, positive. But you already knew that, right? So notice that the cosine and sine are both positive in the first quadrant. In fact, you're going to learn this. A for all sine, cosine, tangent, in fact all the other ones as well, are positive in the first quadrant. And then only the sine, and we're talking about sine, cosine, and tangent, of those three, the sine is the only one that's positive in the second quadrant. And the sine would be the y-coordinate. That's why, because the y-coordinates are all positive when you are above the x-axis. Okay? Alright, so then we get down to here, the 180, or the pi radians. Forgot about that. And we get to the coordinates of this point right there. You go to the left 1, negative 1, and 0 up or down. So we get the coordinates negative 1, 0. So the rest of this unit circle I'm just going to go ahead and fill in pretty quickly, and try to stay with me and try to see the patterns. Okay, so 180, I'm going to add 30 to 210, then I'm going to add 15, then I'm going to add 15 again, then I'm going to add 30 to get down to there. Again, in 6, 7 pi over 6, in fourths, 3, 4, 5 pi over 4, in thirds, 1, 2, 3, 4 pi over 3. So actually I do this in my head. I count by thirds. I want to make sure I'm getting them right. Okay, and then the 7 pi over 6, that's the negative radical 3 over 2 and negative 1 half. Okay, negative radical 2 over 2, negative radical 2 over 2. And then we get negative 1 half, comma, negative radical 3 over 2. Okay, and then we get 0, negative 1. 0, negative 1 there, and we get 3 pi over 2 there. Now the fourth quadrant, we're going to cruise around here. We're going to add 30 to this. We're going to get 300 degrees. Add 15, and add 30. So we get back to the beginning. It's 360 degrees, just like when you had a skateboard all the way around. It's 360. And then the radians, again, we're right here. We've got by thirds, 1, 2, 3, 4, 5 pi over 3. And then we have the fourths, 5 fourths, 6 fourths, 7 fourths, so 7 fourths pi, or 7 pi over 4. And then we have by 6, 7, 8, 9, 10, 11 pi over 6. And again, we've got the 2 pi all the way around. Okay, so the coordinates, again, you're only going halfway. So this, look at that. The x-coordinate now is positive. 1 half, radical 2 over 2, radical 3 over 2. And then, so the cosine then is positive in the first and fourth quadrants. And so, by the way, those letters A, S, T for tangent, positive in the first and third quadrants, and the cosine of those three, positive in the fourth quadrant. So the ASTC, sorry, you really can't see that too well, but ASTC, all students take calculus, helps you remember which sign, which trig functions are positive in which quadrants. But we'll get back to that a little bit more later on. Now the y-coordinate here, negative radical 3 over 2, we have negative radical 2 over 2, and we have negative 1 half. And so I usually give about 5 minutes for students to be able to fill that out completely just like that. And I will see you later. I hope you have a great night.